Welcome back, everyone. I'm pleased to continue today's discussion and welcome Bill Streilein, the Chief Technology Officer at CDAO. Bill, thank you so much for joining us today.
Thank you very much for having me.
Really quickly, a brief overview of what you do at CDAO and what CDAO is. It's something that I think some of our viewers know, but probably more people should.
Sure, absolutely. CDAO stands for the Chief Digital and AI Office. Here in the DoD, it is a successor organization to the Joint AI Center, but also the Chief Data Office at VANA, which is a business analytics platform, and also the Defense Digital Services. It was stood up about 2.5 years ago, and the goal was to actually elevate the importance of AI within the department. Moved from a 3-star body up to a 4-star position, a PSA, which is a principal staff assistant reporting directly to the deputy. And our role is, quite frankly, to accelerate the adoption of not only AI, but data and analytics across the department to help modernize the force. My role as the Chief Technology Officer is to provide strategic technical insights, advice, and sort of define with my team of architects what the reference architecture should look like to accelerate the adoption. And so we support activities across the department, but locally as well within CAO to sort of define how we can achieve these things from a technical perspective to support data analytics and AI. Thank you.
Great. Yes. I, like a lot of other journalists in the space, covered the launching of CDAO and got one of the first interviews with Craig Martell, one of the first directors at CDAO, and he described the first priority for him as understanding and centralizing the Defense Department's sort of key data equities. Because of course the Defense Department has a lot of equities, a lot of different types of data across service, across agency, across office. And so centralizing that in order to understand what AI applications might be appropriate or even achievable was kind of his first priority. And there's been work done with Booz Allen Hamilton to do a little bit of that. But is that mission done? Where does that mission stand today?
Yeah, that mission continues today. It's a great vision to try to recognize, for instance, across that huge amount of data, which are the key data sources, the key data sets that could be leveraged sort of in an enterprise way to support many mission needs. We continue to do that, and actually with the recent announcement of Open Dagger, we're trying a newer approach to it, if you will, that frees up the government's data that is already existing within technology stacks, if you will. And so for Open Dagger in particular, we're taking advantage of a long relationship with a very important partner, Palantir, and enabling that data to be accessible to third-party, capability creators. It's meant to enable more competition between those who have access to the data, so that the stakeholders can benefit the most that they can. So it's an extension of that original vision that Dr. Martell had, seen in the light of needing to open things up to other players, but also having us learn a lot from this experiment, if you will, how that data can be leveraged within the Palantir stack, which is a proprietary stack, but they're opening it up. And so I would say that the vision has continued on. We need to do that and open up the data for everyone to use, and Open Dagger is basically the next step in that process.
Let's stick with that for a second, because that really brings up a couple of things that I think are very important. So when working with third parties, there's a lot of third parties out there that might have something to contribute. There's a lot of foreign partners that the United States military is interested in taking their data, turning it into something useful, and then having that be operationally relevant. But they're among the barriers to fast data sharing and visualization sharing is, of course, classification. Is that a big barrier or obstacle to you in terms of how to ingest this data, get it into a form that can be useful as appropriate by different parties, but still retain, the exquisite stuff retains its security, but the stuff that doesn't need that extra layer of classification can be shared more widely? Is that a technical challenge? Is it an policy challenge? Is it both? And how big is it?
It's actually one of the number one challenges. So you've heard upon in the key challenge, a very important aspect of it. The key aspect of it actually, it's not so much a technical challenge because the ability to share data has been around for a while. It's more of a policy challenge, to be honest. But getting there requires a lot of conversation, a lot of mutual understanding of what the data is that needs to be shared. Having said that, there are sort of newer technical dimensions that are being explored, just like you said, that allow us to determine from a whole data set which portions need to be specially protected and then which ones can be shared as they are. The short answer is that it's both policy and both technical. The one of the things that we are working on, specifically in today's sort of crises that are happening, whether in Ukraine or in Israel, is we're actually getting to leverage those partnerships to understand how that data can be shared. And we're learning all the time. That's one of our key aspects of our strategy, is to do experimentation and develop lessons learned. And the more that we learn from these interactions, the better we'll do going forward to meet the mission need. But it's both policy and technical challenges there.
Yeah, I think that that's fascinating, and it really speaks to managed expectations in terms of what AI can do. Because in order for it to do what we're all sort of hoping or thinking it might be possible, there has to be real human work done in terms of developing different comfort levels with. This is something that comes from 4-stars speaking to Congress and Congress people speaking right back to them. There needs to be new comfort levels and an understanding of how intelligence moves. How to not just retroactively stamp something as classified. And Ukraine provides such a fantastic example of why that can be tricky, because some of the most relevant information about the future of warfare in the world is emerging from that battlefield. But of course, they're not a Five Eyes partner, they're not a NATO partner, and you want to make sure that you protect capabilities where you can. So the conversations that are happening around there really show the need for a new relationship with this information that happens on a personal level and a policy level, and not necessarily on a technical level. But I want to get into another thing that you just mentioned there, which is Advana. This is this data structuring platform. It's very important, for instance, for the Defense Department Inspector General's work, an essential tool by their account for tracking U.S. Assistance to Ukraine. But having talked to some folks from the 82nd Airborne that are in charge of getting things on trains, getting things off trains, and getting them into the field, they I don't mind telling you, they shared some complaints about another data software thing that they had to work with in their day. And as a result of that, the Advana is now in sort of a, how would you describe it? Is it in a re-engineering phase? And what happens next there?
So Advana has, we were talking about at the beginning, the importance of data. Advana has allowed the department to demonstrate the value in bringing the data together. It is, in general, a centralized approach. By bringing in several hundred data sources, you're able to declare them to be authoritative. That, from the technical standpoint, just makes it easier to use. You've got the data pipes right there, the buckets, the S3 buckets that you need to access the data to develop analytics. But then also from a policy level, if you will, or even a comfort level for the stakeholders that are providing the data, they know that within that environment, only those people, those constituents that are approved to access the data can. However, that model is difficult to scale because to get to the point where you are, authorize that data, there's a lot of steps that have to be taken. And so we're thinking about a new approach and moving forward with something that's more distributed. And the idea is to leverage what are known as data mesh principles. It's sort of a newer idea in data management that fits very well with where the DoD is right now with its data. And that is that the data, doesn't have to be brought together into one place. There's a lot of cost to doing that. And so if you don't have to move it in to a single location, you can still reference it. You can still find out about it through metadata that's advertised, and then leverage it when you need it. You don't need to move it into one place, have it waiting there for you to use it. The other thing that's really core about this is that it allows us to think of data not as a strategic asset, which is how I might describe data being viewed within Advana, and being a product. Now, this notion of being a product is something that obviously industry knows very well. It's all about products in the economy, as you can imagine. But for the DoD to adopt that sort of mindset means that we see value when a product gets used by a consumer. And so if a data source, a data product manager actually provides their data in a format someone can use, they see value and basically get rewarded for a consumer, which could be somebody else in the department making use of their data. So with those two things, and there are a couple of other things related to the mesh, related to federated computational governance, and then also self-service access, if you will. We're really trying to open things up so that the next generation, if you will, of data platform can scale, can meet the enterprise needs in a much more flexible and open way. And we hope to see acceleration of people bringing their data sources into this mesh so that others can build capabilities off of it.
Yeah, that's awesome. And from that, of course, you're going to come up with some really cool new potential AI applications. So part of the reason we have this series on the future of AI in the Defense Department is because of the tremendous enthusiasm and public interest right now that surrounds AI, although this series, of course, predates that by a few years. And much of that enthusiasm and interest is, of course, driven by new consumer-facing, public-facing generative AI tools. ChatGPT is the most, of course, famous, but there are many others that work with images, that work with audio, that work with visual, et cetera. Large language models, though, are kind of the one that probably most folks are familiar with. And earlier this year, as we broke on Defense One, the Defense Department launched a task force, Task Force Lima, in an effort to kind of evaluate the appropriate uses of generative artificial intelligence for the Defense Department. So I wonder if you can provide a quick update on what Task Force Lima has produced in terms of insight, reservations, cautions, concerns, or opportunities.
Absolutely. So Task Force Lima, as you indicated, has been around for about a year. One of the first things that the task force did was to solicit potential use cases from across the department in support of that assessment and then the provision of guidance. Well over 200 distinct use cases have been sort of collected from across the department. And with that set, we've been able to evaluate them across a number of dimensions, which we'll get to in a second, and then provide basically some view to senior leadership about where the needs are now, where the needs could be to help guide what's going on. As you can imagine, when the capability arrived, it did really sort of take everybody by surprise. Even folks colleagues that I know who are in the field of natural language processing were completely surprised by this ability. And they refer to it basically as the scaling law of large language models. You keep making the data sources bigger, and you make the models bigger with more and more parameters, trillions of parameters, and you just seem to get benefit from new capabilities that you might not have specifically trained it on. So what we found in reviewing those number of those over 200 use cases is that there are some use cases that we might call low consequence but high scale. That there's a lot of data surrounding these use cases, and then the consequence of a hallucination that might come from the model, or that an error that needs to be fixed in a fact is actual information is low. And those are really some really good sweet spots for this type of model right now, because you can't guarantee that the model won't give you, erroneous output. Not all the time, but it is a statistical model. It's stochastically generating its output, which really is amazing for syntax. The syntax for the language is basically perfect. It's better than humans, actually. But the semantics can sometimes be off. And so in use cases where you have time to correct that, where you can understand how the human and the machine can work together, that's really where you're going to benefit from these large language models. They should not be regarded as an oracle because errors can seep in, and then you're responsible for them, for the error that's generated. So you really shouldn't let the output go out without review. And then another big, so those are like back office sorts of use cases, like filling in forms, like putting together maybe position descriptions. And then, when you have a human that can review it and read it, who's an expert in that domain, it takes a lot less time for them to validate than it does for them to generate. And that's really what you're leveraging this generative AI for, is to cut down the generation time. Another very useful domain for these algorithms is in the analysis of intelligence, whether it's social media or something like that. The algorithms do a great job of just hoovering all of that in and providing a summary. And the intelligence analysis workflow is, again, tailor-made to dealing with probabilistic statements about the world, and also vetting them through a very rigorous process. And so we're seeing a lot of benefit from that as well, that really accelerates the ability to interpret and make sense of a lot of data. So those are really the two main ones. There are others, of course, that are being explored. And I'd say probably our main sort of guidance is that a human should always validate the output. And you should be willing to even change your workflow in order to enable that validation so that you can benefit from its productivity increases.
Yeah, AI applied to intelligence. This is something that the Defense Department has been a big leader on, going back to Project Maven, of course. Originally, kind of an AFSOC, an Air Force Special Operations Command activity, where just hours upon hours of drone footage was emerging from the Middle East, too much for any human analyst to kind of take in, and so it was essential to in that footage provide a tipping and queuing capacity so an analyst could know where to look in this massive stream. Now NGA has that, and we've had a brief update as part of this series on where they are using that in the context of satellite imagery in order to exactly as you said, get an earlier sense of when something might emerge, but that indicator and warner has to go to an analyst that has to work with the machine in that way. So on that, I wonder if you could sort of talk briefly about you mentioned AI is not an oracle, and of course the future is not a destination, but something we write every day. However, it can provide a certain amount of window into a spectrum of probabilities, and that is something that intelligence analysts have to deal with every day. What is the process of helping analysts to really understand and use this tool well? And is the output, is it sort of like this Bayesian thing where you have the output is like a statement about something that might happen, but there's also a confidence interval, a certain statement about a level of probability? Is that the best way to think about what these AI assistants applied to the Intel data set can really do?
Yeah, no, that's a great point, and it actually speaks to this big challenge of bringing in a tool like this into a workflow. The algorithms they put out a probability, what's interpreted as a confidence or a probability. It's not quite exactly what we might remember from our statistics class, because it's not quite that way, but it can be interpreted as a probability or confidence behind the assertion in the statement. It turns out people are not very good at interpreting those sorts of things about hedging the bets. Like I myself, if somebody told me something was 75% probable, I might say, well, it's 3 out of 4 days it's going to rain or something like that. But right, that's hard to take action upon. So these algorithms are really, really helpful, especially the large language models, by actually translating those probabilities into human language, into words. And words like this is probable, this is likely, this is possible, those seem to resonate better with those in the workflow who are used to those terms. And actually, that's the kind of language that is used in an intelligence report. And just saying it using a particular term to express probability to an analyst sits very well with them, and they know what to do with that. They know what to do with that to go find other corroborating sources or to go find other evidence that would then help them interpret that. Like I said, people are generally not good at parsing specific numbers of probabilities, but when they're put into a language, a word to describe the probability, that can then be vetted within the normal workflow. One of the major challenges with incorporating what I guess might be called narrow AI or classical AI, a neural model applied to like imagery for detection, is exactly that, is interpreting that quantitative expression of probability from the algorithm in the context of a decision about what to do. It's people are naturally better at responding to a description of it as opposed to the actual numbers themselves.
Yeah, yeah. That's fascinating. That relationship that needs to be developed and learned between humans and this tool in order to make both comfortable. I think that's something that's sort of left out of this a lot, and it's an area where the U.S. and I think particularly the U.S. Military and intelligence communities are really excelling because. Of course, there is this emphasis in U.S. government AI development on human-machine teaming. It goes back for years, but I think in many ways most publicly to Bob Work and some of his ideas on Centaur chess and the need to really highlight that human-machine team as superior simply to something that runs almost automatic or something that's simply eschews modern tools like AI. So I think that's a really good point, and you see I think so many ways that's going to set and paint a future of AI that is specific to U.S. and hopefully incorporates to a certain extent U.S. values. I think that's fascinating. Let me ask you really quick on trade winds, which is this big thing out of CDAO to bring in and in many ways encourage and boost smaller, non-traditional partners, software developers, new startups, if you will, and outside of DoD or outside traditional defense contractors who might have something to contribute to this. What are some of the big accomplishments or key contributions that have emerged from Tradewinds?
So yeah, Tradewind, as you said, on the face of it, is an environment that allows non-traditional vendors to come in and basically see requests or see requests for proposals or from program managers within the department. They leverage, and I'm not an acquisition executive, so I'll probably use some of these terms wrong, so please don't hold me accountable for that. But like an OTA, another transaction authority, is a different way to bring in a capability that's meant to deliver prototypes, but these prototypes can have operational impact. What's really nice about Tradewind is that it's, again, a really nice match with where we are in the adoption of data analytics and AI. We need to do experimentation. The technology is changing, literally on a daily basis. New capabilities show up. And we can't wait for the typical 2-year acquisition process to bring something in, and then it can't even specify necessarily the technical requirements that we need because they're always changing. So with Tradewind, we have a much quicker way of getting in a capability against a need that we have, trying it out under an OTA, and then from there start to understand, well, what would a more sustainable program look like? It also allows us to address issues with competition, like across the field in terms of where solutions can come from. And through those mechanisms, we've really been able to open up to non-traditional vendors, but also folks on the other side, inside the DoD. They now have much better awareness of how big the playing field is for who can provide capabilities to them. It's core to the Open Dagger mechanism that I mentioned previously, and we're continuing to expand it with specific mechanisms for not only technical capabilities, but talent, data, and even T&E solutions that folks within the department that want to leverage these modern ways of doing things can rapidly try to see how they're going to work out in their workflows.
Yeah, I think that brings up a really interesting point, which is talent and preparing a very unique and diverse workforce for the future for using AI tools. Because there are businesses, of course, where you have one person that probably needs to know how to use a future AI tool. Everyone else does different things. The Defense Department is not one of those businesses. And I think something that's really interesting that's coming out of the discussions is this awareness that technical sophistication, particularly around data, is going to be a key capability for a lot of people in very diverse roles in the Defense Department. I'm thinking specifically, again, of the 82nd Airborne and the new work that they've done to create a data literacy course for folks that normally jump out of planes. So they'll still be jumping out of planes. Don't worry, I'm reassured of that. But they are also developing an understanding of the data that they might be using operationally to create things very much in moments of kind of intense, very intense moments that the 82nd Airborne can tell you about on their own. So talk to me for a brief moment, and it's outside of the scope of CDAO right now. It's not your job is not to train everybody across the Department of Defense on the core new literacies or academic underpinnings they need to really engage with this stuff. But how do you see the arrival of these tools, just as an expert practitioner, in forcing the development of new capabilities, competencies in the Department of Defense across people of different roles?
Yeah, no, actually, we have a digital talent management team here, a directorate that's focusing specifically on improving the literacy of the department with regard to these digital technologies, both data analytics and AI. Obviously, there's training within Advana, but one of the major challenges within the department, especially in the military, is that there aren't now what they call MOSs, which are basically career paths within the department that acknowledge that you're a data scientist, that acknowledge that you're an AI expert. There are technical positions, of course, ORSAs and things like that, but it's not necessarily their main career path. They can continue to develop and learn on. So we actually are pushing 11 different career paths within the department that allow codes, if you will, that allow somebody to, a leader to request a given person with AI expertise. People can now push themselves into that career. They can get training for it and then basically move forward. In addition, we have a number of literacy courses for different echelons. We've just launched this year 3 different executive leadership courses for AI. One's at MIT, one's at Johns Hopkins, and one's at the Naval Postgraduate School. These week-long courses basically immerse senior leaders in the notions related to data analytics and AI, to help them sort of dispel the mystery around it and think sort of rationally about where this capability is. And the more that they know about it, the more that the leaders know about it, and then as we move down the lower echelons, the better decisions they can make about how to bring the capability in to the department. So we're doing a number of things, and we actually find that it's a way of sort of preparing the battlefield, if you will, for us, because when we go and talk to stakeholders in the department about what needs to be done for adoption, we have now a common lexicon we can use to talk about things, and they're able to rationally and effectively deal, in some senses, with vendor pitches that might be more grandiose than they really should be, they're able to really recognize what the capability is and see how it fits in. So it works in a number of dimensions to help us with our goal.
Yeah, that's really awesome. That's, I think, so important to help develop really an entire workforce to be prepared to use all of this stuff. So one portion of the workforce doesn't worry and fret about automation or outsourcing. It's really, especially when you're talking about the ever widening business of national security, there's a lot of room for really all sorts of different people to begin to engage these tools in a way that is just going to help the entire mission. But on that, of course, there's no greater instructor than the real world. And right now, just watching geopolitical events from Ukraine to Israel, where you see a lot of innovation happening digitally, more and more stories emerging about militaries using AI and lethal autonomy in combat. The U.S., of course, does not have boots on the ground in either place. The U.S. military does have in place a very lengthy list of AI principles to govern lethal autonomy, which we broke the story on, and I encourage you all to go and look up. But just as an observer, what are some of the key lessons that you are taking away from these conflicts in terms of effective and responsible use of AI military?
Well, we've talked already about the need for sharing data across different partners, right? Because we're not, with the support that we're providing is not just us, it's partnerships with other nations as well. And so there's the technical aspects related to how we share that data, but there's also agreement in terms of what those responsible AI terms mean. We have our definition here in the DoD. Other nations within the Five Eyes community, for instance, have similar definitions, but they're slightly nuanced. And so being able to talk about those differences and see where the seams are between them so that we can then move across them to share the data is one of the biggest lessons that we've learned. It just takes communication. The goal is eventually we'll have these things ironed out for a particular workflow, particular support role or something like that. And then as we encounter new types of data that could support it, we hopefully can go more quickly in revisiting and saying how that data should be shared, whether it's across classification lines or whether it's on other lines that are related to the support that's provided. Some of the things that we see is the ability to quickly generate a capability is very, very important. And the ideas can come from anywhere. So, we sponsor hackathons that allow us to develop capabilities very, very quickly. Again, this speaks to enabling, very capable digital individuals, digital natives, you might say, but these are people who can quickly generate a capability on relevant data and just demonstrate proofs of concept. And through the GUIDE experimentation series, which is the Global Information Dominance experimentation series, we're showing how those capabilities have mission impact, but importantly, have a path to be a leave behind for instance, the combat commands where those capabilities are needed, whether it's to make sense of new data or to do some planning related to how we're going to provide that support or something like that. And so this need to continuously experiment is probably one of the biggest lessons we've learned as well. And doing that experimentation with partners is key as well.
Yeah. So I think that's great. And it reminds me of something else that has come up recently with more and more of this emphasis on AI and more realization of how it's going to change entire fields of business and human activity. There's a kind of growing awareness about its resource use. Artificial intelligence, by some estimates I've seen, uses the amount of energy of the Netherlands by the year 2027 is one estimate. I'm not sure how each of these estimates is supposed to sort of compare with one another, but I think there's a universal understanding that all of these CPUs doing all of this regressions, it has a big footprint environmentally. The Defense Department has an interest in reducing the amount of energy that it uses, both because of the wider effects of climate change and more specifically an operational need to reduce the amount of energy that it uses. Can you tell us a little bit about some of the strategies that might exist to allow the Defense Department to accelerate its use of AI while also possibly reducing or mitigating the amount of energy that's required to run AI as it exists right now with the systems, with the servers, with the processors that exist now, and maybe what's to come after them?
Yeah. So, I mean, as we know, these models, especially the latest generation, the frontier of AI, if you will, can take months to train, and they use an enormous amount of energy, resources, natural resource that support it in the form of computation, obviously. And then even when you go to execute them, that is, use them at what they call inference time, where you're, sending a prompt in or something like that. They continue to use energy, not as much over such an extended period of time, but when people start asking questions, that's when you start to use it. So there's a number of things that we're looking at that can help us make sure that we're doing it responsibly. The responsible AI terms are more about, right now, is at least as articulated in the ethical principles memo, are about making sure that the use of the AI is along with our values here in the U.S. Right there, it's equitable. You can govern it. It's traceable, so you know how how the result came to be. It's reliable in a military or in an operational environment, and then it's responsible, of course. But with this extra aspect of the resources being needed to be used, it puts a new sort of spin on this, that we realize that the resources aren't unlimited, and that the impact is there. So, there's always been a trend in computation in electronics in general for miniaturization, and the miniaturization tends to use less power, tends to do similar types of computation with a smaller footprint, This has just been a trend over time. And we know about Moore's law has, sort of maybe dying out, if you will, the ability to say that you can get twice as many transistors as you could before with the same power is maybe something that's nearing its end. But new architectures for doing that computation are very promising. And so there's a lot of government-sponsored research to look into these architectures that leverage neural principles. These principles are learned and invented, of course, by scientists, but certainly learned and witnessed in the brain how nodes of computation form a network, a neural network, if you will. And this, as opposed to serial computing that's happening most often in CPUs and in some senses DPUs as well, that neural architecture can do a very similar type computation with much less power than is normally done. And so there's a lot of work to be done there to explore that. And we are looking at that to see how that can help us. It's not necessarily widely adopted, but of course, this is the way research goes. You want to find something that can address a problem in the future and continue to push on it and work on it. The other thing is, I mentioned earlier, architectures will allow us to take advantage of space that we have without having to move data around. Because moving data around is, I mentioned the cost aspect, but it's also resource intensive. So if we can come up with other architectures that can bring solutions in an enterprise way, such as the mesh, which leaves the data where it is, but only shares the metadata, that can make it more efficient and use less resources as we're supporting those analytics. So there's a number of aspects that we're exploring, and we are definitely aware of it, and it is a consideration when we think about how to leverage these capabilities for support.
Yeah, I think that's great. And if you look at the DoD research and engineering priority in microelectronics, you can follow some of our coverage of DARPA sponsorship, for instance, of neuromorphic chips and new architectures. You can really see, I think, and especially taking into consideration your comments, the emergence of an entirely new industry, an entirely new way to think about computation that's aligned with the fundamental physics of the way human beings live, with metabolism and the amount of energy it takes to do something like track a bird across a plane, applying these things that exist long before humanity to what humanity does now, an entirely new frontier for computation. So, Bill, thank you so much for joining us today. Thank you to our audience for tuning in. I feel like a much better understanding of how AI is going to apply to the Defense Department, how the Defense Department is applying itself to the future of AI. In case you missed any of today's conversation or wanted to share it with your friends and your colleagues, it will be available on demand in 24 hours. Thank you so much. I'm Patrick Tucker, Science and Technology Editor for Defense One.